Hello and welcome. In this video I'll be talking about Venn diagrams and set operations. So in a previous video I introduced the concept of sets. So a set is just a collection of objects that we usually call elements. And so in this video we'll be looking at how we might think of interactions or operations on sets. So I'll introduce a few new terms. So one that we'll be using in this video is the universal set, and usually we name that with a letter U. So U is the universal set. And so just as an example, let's say that our entire universe is the set of natural numbers from 1 through 10. So I can define U using what we call the roster method by listing these elements 7, 8, 9, and 10. All right. So like I said, in this case you can think of this as being my entire universe. And now I can create proper subsets by such as like A, and maybe that is just the even numbers from my universe. So 2, 4, 6, 8, and 10. And let's do another one that we'll call B, and maybe this is just the smaller numbers 1 through 5. All right, so a Venn diagram is a tool that helps us visualize our sets and their relationship to one another. So the way that a Venn diagram works, we start with a frame. Usually you'll just use a rectangle, like a picture frame. And this represents your universal set. And oftentimes we'll put a little U in one of the corners. So the numbers, the frame, or my universe, contains all of these numbers 1 through 10. Now, the set A lives within this universe, and I can represent that using a circle. So this is A. And this has the elements, let's see, 2, 4, 6, 8, and 10. And in B, I have the numbers 1, 2, 3, 4, and 5. Now, I'm going to draw this so that there's some overlap between these circles. And the reason I'm doing that is because the numbers 2 and 4 certainly are a part of A. They're here, but they're also elements in set B. So I'm drawing that in this overlap between A and B, but B also has 1, 3, and 5. Those are in B, but they're not in A. Now, as far as elements that are in my universe, but which are not in either A or B, let's see, what do I have? There's a 7, that's not in either of these sets, and a 9. So 7 and 9 live out here in the universe, but not in either set A or B. All right, so that's how a Venn diagram works. Now, just to so you know, there's some other concepts that we can illustrate using a Venn diagram. So if I draw my universe and then two sets, A and B, without any overlap, this means that A and B do not share any elements. And we say that A and B are disjoint. So there are no elements in common. I'll just say /shared. So this is a Venn diagram to represent that concept. We might also have our universe and a set. We'll say this is B, and maybe A is completely contained within B. In this case, I would say that A is a subset. Well, actually, I know that A does not equal B the way that it's drawn here, so it's a proper subset of B. A is a proper subset of B. And lastly, for now, I'll draw another picture where it looks like A and B are actually equal to one another. So the same circle could be represents both A and B. So this is where A equals B. So they have all the same elements, exactly the same elements. Okay, so let's look at ways that we can talk about maybe combining sets or forming new sets. Three terms that I'm going to be using are complement, intersection, and union. So the complement of set, and I'll just say A, set A. So the complement of set A is the set of all elements in U. So in my universe, not in A. And the notation that we use for this is, for the complement of A, is A, and then depending on where you look, sometimes you'll see an apostrophe, so that's A's complement. Other times you might see a superscript of a C, or you might see a bar over A. This is the one that I'm going to use, so an apostrophe. So this means A's complement. So everything in the universe that's not in A. All right. Going back to the previous example that I had, here where A is the elements 2, 4, 6, 8, and 10. So A's complement would be the set of everything that was in my universe not here. So all the odd numbers, 1, 3, 5, 7, and 9, that would be the complement of A. And of course we could do B's complement. That would be everything that's not in B. So the numbers 6, 7, 8, 9, and 10. All right. The intersection of sets A and B, and this is denoted with something that looks kind of like a, it's not really an N because it doesn't have a snap on it, but it's just a curved shape that opens down. So that's the symbol that we use for intersection. The intersection of sets A and B is the set of elements common to A and B. And in fact, sometimes this is called A and B. Now, again, let's go back to this first example. So A intersects B. That's this, in the Venn diagram, excuse me, that's this region right here. So it's the overlap, it's the things that are shared, and so this is the set that contains the elements 2 and 4. That's the intersection. All right, and then lastly we have the union of sets A and B, and that's denoted with this symbol turned the other way, so it does sort of look like a U. The union of sets A and B is the set of all elements, and I should say in your universe, elements, I'm going to just add that back, in U, that are in A or in B. So this is kind of a marriage between these. It makes a superset by combining the elements of A with the elements of B. So let's see, A union B is the set. So I'll take everything that's in A and everything that's in B. So 1 and 2, because I'm pulling the 1 from set B. Now, there's no need to repeat something that's in both sets. So 2 is there, and it's 3 and 4, 3 and 4, 5, 6, 8, and 10. So that's the union of those two sets. Now the union is this like figure 8 shape. That's everything that's in both of those. Alright, so those are the basic, that's the basic vocabulary: complement, intersection, and union. Alright, so we can create a lot of different other sets and visualize those using Venn diagrams by looking at different combinations of intersections, unions, and complements. So how would I represent a complement in a Venn diagram? So here I have my universe. Here's set A. All right. Now if I want to represent A's complement, so that's everything outside of A. So the shaded region is A's complement. Let's see if I want to say, this is one I've already done, but I'm going to just have everything in one place. So let's look at the intersection. So here's A, here's B, and let's look at the region that's A intersect B. So that's the overlap, so that's this region. For the union, A union B, so here's A, here's B. So the union makes one big set from the two, and so that's this region. Okay, so now what about if we take, for instance, the complement of the intersection? So if I want to take A intersect B, but take the whole complement of this, so here's A, here's B. Now this is the intersection. Now this says everything that's not in the intersection. So that would be everything not in that intersection. So I'm trying to shade everything except this region. So it's like the opposite of this guy here. What about if I have A and B, and I want to talk about the complement of the union. So there's the union. Excuse me. And I'm going to take so everything that's not in the union is outside of here. So these are the elements in the universe that are neither in A nor B. Let's see. And of course, there are many other things. I'm just going to go through a few more. Let's see. What if I said A's complement intersected with B? So A, B, and A's complement intersected with B. So A's complement is everything outside of A. So that's the shaded region. So where does that overlap with B? Well, that's here. So it's the part of B that's not included in A. That's a kind of a tricky one there. So remember here, might help if I actually had B in this picture. So I'm thinking of A's complement, that was the area shaded in red here, but where it overlaps with B is just this part of B that's not in that kind of, I say like a football shape. What about A's complement union B? So here's A, here's B, and A's complement, we know that's everything here, but that's together with everything in B. I'm creating a superset, so it's certainly going to include everything in B, and then everything in A's complement, and so basically we end up with, the only thing that's not shaded is, this region. Let's do a few more. A's complement union B's complement. So here's A, here's B, and I know A's complement is this region that's everything outside of A. B's complement is everything that's outside of B, and when I union those together, so here's A's complement, and now let's do B's complement. Everything outside of B. Now notice I've shaded everything except the football. Now that looks familiar. That is the same thing as this guy right here. These two are the same thing. Those are equal to one another. So the complement of the intersection is the same thing as the union of the complements. That's an interesting fact. All right, and then let's do, let's see, that was the union, and let's also do, the A complement intersect B complement. So that's the overlap, and so that's this region here. A's complement, that's everything here. B's complement would be, everything outside of B. And so the things that those two share in common are this region in the universe that's not in neither A nor B. And now again, let's see. We've seen that before. That's the same thing as this guy. And so here we have the intersection of complements. That's the same thing as the complement of the union. All right. And then lastly for this video, I want to just talk about the how this might involve the empty set. If we take A and we intersect that with the empty set. Well, the empty set doesn't have any elements in it. So if I ask what they have in common, the intersection of A with the empty set is still the empty set. And if I take A and union the empty set, then that's just going to be A. All right, so those are some of the just basic ideas of the set operations and how we can represent those in a Venn diagram. And so I'll come back in another video and we'll look at some applications and get some practice with these concepts. All right, hope to see you then.